So today what we're going to do is kind of set the foundation for everything. Because I really believe that anyone can do this sort of thing, can like add a game theory strategy element to their game. The one thing that it takes is hard work. But the thing is, with a little bit of hard work, you still get some results. And with a lot of hard work, obviously, you're going to get more results. And that's really like been the number one question around here for like the last like several months is, how do you, it seems like you're standing at the bottom of a mountain and like, how do you take steps toward that? And that's going to be the goal today is take steps toward, the bigger goal. So there's going to be, there's going to be some numbers and it's going to be some maybe kind of silly examples, but it'll get us to a point I want us to be at. So tell me where where do you think your edge came from when you were, beating the best players in the world?
Um, Being able to read their hands well, being able to narrow down what kinds of hands they were playing in different positions and how they might when they might tend to widen or narrow their hand ranges depending on what's been happening at the table. Mm, Dynamics, I guess you would call it. But really just being able to guess really well at what they'd be holding by the major decision points and kind of understand how they would react to my decisions with that range.
Yeah, I think I think kind of in like in these terms or like in the game theory terms, it's just, playing a very strong exploitive game. Like you know exactly like what someone's weakness is and you can attack it kind of thing. Or if they have a tendency to do too much of something, being able to attack that. Is that kind of a fair?
Yeah, more or less, if somebody's folding a lot to three bets, I'll three bet them a lot, and I'll call with aces and kings, um, things like that. Yeah, definitely. If they're folding a lot to continuation bets and three bet pots, I'll three bet them a lot and continuation bet a lot with my bluffs. And those are, I think, some where some of my edges would come.
Yeah, so I think it's a type of thing where we can use game theory to build on that and to kind of put that front and center so that you can take your good reads and do kind of more with them from a structural standpoint. So, I mean, the whole point of doing this is we want to have this systematic approach to just plugging leaks. You know, be able to say, I play a range this way in this spot. What can my opponent do to easily exploit that? And kind of getting rid of that sort of thing. And also just being able to understand exactly, how your range coordinates. And your range could be, we get to this specific river card where you've, bet the flop and check called the turn. It's so, it's one of many different ranges that you're going to have, and understanding exactly what hands you get there with, I think is a really important thing. So the one thing, and I mentioned this before we started recording, but the one thing that is really important is if you're not following something, please stop me because I guarantee, like, if you think you have a question, there's probably like 100 other people that have the same question, and it's just kind of my fault for not explaining it.
Oh yeah, I'll definitely stop you.
So I want to first go over some questions, and we'll hopefully be able to answer all these questions by the end of the video. But I'm going to kind of put you on the spot here, expecting basically just hoping to be able to compare at the end, your answers to your answers right now.
Hmm.
And if you don't know the answer to any of these, just we'll move on past that. So, what's equity beyond just like what Poker Stove tells us?
Well, if you had a bunch of hands involved in a pot, or let's say two hands, however many hands really, and you ended the hand right now, what piece of the pot would be yours based on your holding?
Okay. And what does EV tell us, and how do we calculate it?
Um, EV tells us how profitable a certain play may be, and we calculate it using an EV calculation, which is kind of like basically equity our equity in the pot when we win, the amount of money that we gain when we win, minus the amount of money that we lose when we lose.
Okay, these are good so far. So why might game theory be good for a great exploitive player?
Well, because a great exploitive player, really, they're probably leaking in certain areas against unknown players. And even beyond that, even if they're not leaking in areas versus unknown players, it just gives them a kind of a mathematical foundation in order to in order to make better decisions. I guess going back to playing against unknowns, there's just a lot of situations in which you don't have enough reads to make the most profitable exploited play. In that situation, an exploited player is generally guessing at what the best play would be based on previous history or making kind of general assumptions. And what game theory can do is just eliminate that guesswork from the equation completely and make the decision-making process just much simpler.
Yeah, so I don't need to sell you on it then because I mean I think that's pretty much exactly the case. And we'll see an example of that kind of in action. So these next ones a little more technical. So what's Bayes' theorem?
Bayes' theorem, as far as I know, is a theorem that kind of says, for instance, like you sit down at a table and a guy in early position like raises the first three hands that you notice. You can like Bayes' theorem allows you to say there's a high correlation between the fact that he raised and the possibility that he can be a loose aggressive player or have like a loose aggressive range. Um, it doesn't preclude you from, at least this is my understanding, it doesn't preclude him from just having sat down and picked up aces three times, but it allows you to draw like these, I guess, probabilistic reads, something like that.
Okay. This one I assume.
I don't know what this is.
Okay. And then
Nash equilibrium would be the I guess the equilibrium. It looks like the solution to a game in which if you employ it, no one can be profitable against you. It's like the uh, the game theoretically optimal solution to a game between two opponents. I
okay.
guess there can be more than two opponents, but with a Nash equilibrium,
Yeah, there can be. Though I know it gets like a lot more difficult with multiple players. So then this is the last question. Is this stuff hard to
is
do?
this stuff hard to do? Um, Hmm. That's a relative question, I think. Is it hard to do for me right now? Yeah. Is it hard to do in general? I don't know. I don't know that it is. I think that it just takes some work and some learning, and then once you have learned it, it becomes pretty easy extension of your poker playing in the way you analyze poker.
Yeah, I agree with that. And I also agree with the first thing you said. I mean, it does take, it does take considerable amount of time. Though I do feel even with a small amount of time investment, you still see returns. It's like not like you have to solve poker to get any sort of returns. I think that's a nice thing about it. You kind of reap the rewards along the way. So we're gonna set up a little toy game. So like this little, it's an actual poker hand, but it's very specific. But we can kind of see how some of the numbers are working in a simpler context without jumping into these crazy, big range versus another big range and all these calculations and stuff. So we're gonna be on the river. Doesn't matter how we got there. The board is three deuce deuce five six. Basically, just think of it as very dry. Um, the pot's 1250, stacks 1,000, so we have a little less than a pot size bet behind. And the out of position player can either shove or he just mucks his hand.
Mhm.
So we're gonna look at a couple. We're gonna look at a few hand versus hand comparisons, and this is where I said it's gonna be kind of a little silly because it's kind of unnecessary, but it'll lay the foundation for running these sorts of calculations. So for each of these matchups, I want to look at the equities and the expected value of folding, the expected value of betting. So let's fill out this table, and I'll walk you through how we can fill out each one, and this is going to give us the equity for our hand. So what are all the possibilities for hands our opponent can have?
On the river?
Yeah, just right here. I mean, I don't even know how to phrase that. He always has 2 of clubs, 2 of diamonds.
Okay.
So how many combinations of that are there?
1.
And
100%.
yeah, 100%. Yeah. And how often do we win against that hand
Um,
on the river? You want me to pull the board back up?
no, I mean, I think 0. Well, I don't know if you have a straight flush draw, but if
No,
you
because
do.
we're on the river.
Oh, right, right. So
Yeah.
0% unless we
Yeah.
kill him.
True. So then for this, we just multiply these 2 together. So what's just 100% times 0%?
0.
So that's simply how you calculate equity. It's kind of a weighted average of all the possibilities of, you winning or losing. We could be on the flop and we could be looking at, each type of board run out. The flop is 3 deuce deuce. What if it comes ace of spades, king of hearts, ace of spades, king of diamonds, ace of spades, deuce of diamonds, or, and so on. And we would just kind of take a weighted average of all of those possibilities. And that's what equity is. It's just a weighted average of all the possibilities and your chances of winning given each of those possibilities. And you plug this thing into PokerStove, it tells you 100%. I mean, that's what you'd expect. Quads are always going to win. So how about calculating the EV for the player with 6-5? So what would the in position players who has the quads, what's his strategy?
What's his strategy with quads?
Yeah.
We'll never fold.
Yeah. And so we still want to look at our EV of each possible strategy, or the out of position player's EV of each possible strategy. Like right now, what would you think is, well, that's kind of obvious. Anyway, so the EV of folding is 0, and the EV of folding is always 0. It depends.
So, sorry, maybe you should finish, but I was just going to say I've heard recently that the EV of folding is not always 0.
So it depends where your frame of reference is, and there's been some debate over this, but it's not even debate because it depends when you're looking at. Like if you're looking at the context of, say, calling the flop and then folding, like when you're going to fold the turn, then yeah, it costs you money to call and then fold the turn.
Got it.
But when you're facing a bet on the turn, your EV of folding is still 0. So it depends on your frame of reference. At the current moment, when you're sitting there facing a bet, your EV of folding is always 0.
And why is that?
Because we'll kind of see when we calculate the EV tables, but it's basically just a weighted average of all the possibilities. So what are given that you fold, what are the chances that you fold?
100%.
And what is your net profit when you fold?
0.
Yeah, so it's just 100% times 0.
Got it.
And then let's try to figure out the EV of betting in this situation where we're always getting called and we're always losing when we get called. So the pot was 1250. The effective stack's 1,000. So what are the 2 possibilities that can happen, assuming that we don't know our opponent's strategy? Like we don't know if he's calling or folding.
Well, this is assuming that our only bet is all in.
Yeah, our only bet's all in.
So, I mean, we can bet 1,000 and win 1,250. So we can win 2,250, or we can lose, or we can lose 1,000. Or we can lose, yeah. Oh, I guess we can win 1,000 or lose 1,000. Oh, sorry, win 1,250 or lose 1,000.
Yes, exactly. So he can either call or he can fold. And we know he's always calling and never folding. If for some reason I don't know, we had some read that he does something different, then you'd be able to change the numbers. So the way that I approach this, and I think it's useful from a standpoint of understanding the way that the EV works, and keeping the frame of reference consistent. So for this dollar column, I'll always do how much money will be in our stack at the end of the hand. So if our opponent calls us, how much money will be left in our stack?
0.
And if our opponent folds, how much money will be in our stack?
2250.
And so what's the net then? It's just this minus the 1,000 that we started with, right?
Mm-hmm.
And then again, we just multiply. So this is another weighted average. So, 100% times negative 1,000 is negative 1,000. And 0% times 2250 is $0. You sum those together and you get negative $1,000. So, I mean, intuitively, this should make sense. What's the EV of betting what's the EV of betting 1,000 when you're always getting called and always losing? You're just lighting money on fire.
Right.
So now let's go through these quickly. If you've got quads against a full house,
Mm-hmm.
what's your equity?
If you have quads versus full house, I don't know, 97%.
Well, we're on the river.
Oh, 100%.
Yeah, so our equity with quads is 100%. What's the equity of a pair against air?
A pair against air,
Just
100%.
Okay, and then what's the EV of folding?
0.
So what would be the EV of, say, betting quads if your opponent's always calling his full house?
The EV of betting quads, plus 1,000.
Well, you're getting the pot, so
Oh, plus
1250. Yeah.
1250, sorry.
Yeah. And then what's the EV
Well,
of betting?
you're getting plus 2250 though if he's always calling, right?
Oh yeah, you're right. You're right. Yeah, you're right. And then a pair against air. Let's assume he's always going to fold.
So plus 1250.
Yeah. Okay. So hand versus hand is just really not interesting, and yeah, there's really not much to talk about there. But I think it gave us a foundation for calculating the EVs. So we're going to look at a situation where we are at a position with the pair, and our opponent is in position with either nothing or the nuts.
Mm-hmm.
And again, we have this option of betting 1,000 into 1250 or just open folding.
Mm-hmm.
So let's calculate the equity again. So how many, if we have 6-5 of hearts, how many combos of quads are there?
1.
How many combos of 6-5?
0.
And how many combos of 8-7?
1.
So we sum that up. That equals 2. And then to get the percentage of the whole range, we just divide by this total. So it's, 1 divided by 2, 0 divided by 2, 1 divided by 2.
Why do we do that?
To get the chances that when we hold 6-5, what are the chances that our opponent has deuces? What are the chances that our opponent has 8-7?
Oh, okay, I see what you're saying. There's just 2 other hands, and there's only 2 combos total.
Exactly. So there's 50% chance you run into either hand.
Okay.
And we want to figure out the chances that this event occurs, that he has deuces or he has 8-7, times the percent of the time that we win when that happens.
Mm-hmm.
So when he has, or we win at showdown, if all in. So if he's got deuces, how often do we win?
0.
We don't care about this case. And if he's got 8-7, how often do we win?
100%.
And again, we just multiply these things and then sum up the column. And that's going to be the theme for a lot of these things. So 50% times 0% is 0. 50% times 100% is 50. You sum these up and you get 50%.
Mm-hmm.
And I mean, that's intuitive because, there's a 50% chance you have a better hand, 50% chance you have a worse hand. So you're just going to eventually, if you just deal out the cards, you're going to win 50% of the time.
Right.
So now in this situation where we've got 6-5 of hearts out of position, and we bet, what's our opponent's strategy going to be? And he knows what we have. He doesn't necessarily know our strategy, but he knows our hand.
Hmm. Well, he's going to, and he can only call or fold,
He can only
right?
call or fold, exactly. And these are
So,
the hands he can have.
well, so he's gonna call pocket twos and fold 7-8 of hearts.
Exactly. But we still can calculate our EV. So it seems like, I mean, this seems terrible, right? Like, why would you bet when he's just going to, call with better hands and fold worse hands? It sounds like it doesn't make sense, right?
Um, if well, let me look at this again. If he, why would wait? Who's betting? Who has what? Oh, Hero's the better with 5-6 of hearts. So we're talking about why would you bet if you were Hero?
Yeah, so we're
That's the
out of
question.
position. Our options are betting and getting called by a better hand, making a worse hand fold, or just mucking our hand.
Oh, I see. Yes, right. So I'm with you.
So the thing is, we are when we bet, we still have a chance of winning the pot. And when we fold, we don't. So everything's relative. We're always comparing the EV of all the possibilities at the moment, and we're going to choose the option that has the highest EV.
Mm-hmm.
So in this particular case, it actually might be the case that betting's better, but we can go in and find out. So again, the EV of folding 0 of that particular action, given that you're facing a bet, the EV of folding 0.
Mm-hmm.
The EV of folding, let's say the in-position player is planning on folding. That whole strategy is going to have some EV if his opponent will fold sometimes and give him the pot. But given that he's facing a bet, the EV of folding 0.
Okay.
So let's try to fill out this table. So we know that deuces were 50% of his range. We know that 8-7 was 50% of his range. What happens when he's
Lose
got,
1,000.
so we can put that here. So, but for this, we want the final, well, actually, let's do this first. When he's got deuces, we get called. When he's got 8-7, he folds.
Mm-hmm.
He's going to do that with 100% certainty. We know he's always going to call his nuts and always going to fold his air. So what's our final stack?
Minus 1,000 with pocket twos. Our final stack is 0. And our final stack is 2250.
So then effectively what we want to do is first we want to find our net profit for this situation. So 0 minus 100, minus, 1,000 for the top. So if we have $0 in our stack, then we have $1,000 less than we started with.
Mm-hmm.
And we want to multiply that. So we want to multiply our net profit by the chances of this occurring. So that's why we keep all of these percent columns, because then we just multiply them together at the end.
Mm-hmm.
And we're just kind of recreating this new sort of range by taking all the pieces and putting them together. So it's just like that. 50% of the time, we lose $1,000.
We would do well 50% of the time we win 1250.
Yeah. Okay, so what's our total EV then?
Plus 125.
Okay, and I think this is something I've been doing. I think it's kind of interesting just to think of it in the terms of, the one money at showdown and one money without showdown. So what would be our without showdown winnings here?
Plus 625.
And then what would be our, should not be red. Uh, what would be our one money at showdown?
Minus 500.
Exactly. That's not particularly useful right now, but it's something that I just kind of wanted to set the framework up for. So what's the better play then?
To bet.
Yeah, exactly. When it seemed like betting didn't really make a lot of sense. But that brings up the point that context is so important. If you're in position and you could check it down with 6-5 and beat 8-7, then you would do that because the EV of checking is positive. But when you're forced to fold, then the EV of, your alternative is just zero EV.
Right.
And that's just really important with this. We're always comparing the EV of different lines, no matter what the situation is. And we're not just looking for a plus EV play. And you know this intuitively. You're looking for the best play. You're not just looking for, a good play. It could be plus EV to, jam a draw for 100 big blinds in a flop, but doesn't make it the best play.
Mm-hmm.
So just simply, betting's better than folding. So let's flip the situations around. We are now the player in position facing a bet, and our opponent can have one of these hands. So this is the exact same equity calculation. We still have the same hand versus the same range. So I want to do, a lot of this is going to be kind of theoretical, and I don't like the theoretical stuff. I like practical examples much better. So I'm going to try to, mix that in as much as possible. And so what this is Card Runner's EV. And all I wanted to do is just look at this very simple game where, this is exactly the model that we set up. The stack's 1,000, the pot's 1,250. You don't need to understand at all how this software works. And we're just focused on the river here. So the out-of-position player either has quads or air. The in-position player always has a pair. And, we can compare the EVs of a couple of strategies. So pick a bluff percent for the out-of-position player.
Bluffing with 7-8 of hearts.
Yeah, exactly.
I don't know. Let's say 60%.
And then pick a bluff catching percent for the in-position player.
And he's got, what does he have?
He's got a pair.
He's got a
pair.
So
he beats the air and he loses to quads. And as we saw, it is in our opponent's best interest to at least bet his air sometimes.
Right. Let's say 75%.
So, we could plug those in, run the equities, and, you see that the player out of position, his EV is 869, and we'll get to the EV for the in-position player because it's not this 164. So let's say we know exactly how the out-of-position player is playing. He's bluffing 60% of the time. Let's try to figure out what our best strategy is. So this is where, exploiting someone comes into play. We don't know what the perfect play is for this little game here, but if this is not perfect, then we want to exploit that to the best of our ability. So the question is, whether or not calling with 6-5 is plus EV or not.
Mm-hmm.
And if it's plus EV, then we'd always call. If it's minus EV, then we'd always fold. And it's that simple. So let's try always folding and see what the EV is for our opponent. Because our goal now, since we're exploiting, is we want to minimize our opponent's EV, which is the exact same thing as maximizing our own EV. Do you follow that point?
Say that one more time.
So if you look here, where the small blind is here, this number 3,
mm-hmm.
The total EV for the small blind strategy and the big blind strategy will always equal the size of the pot.
Okay.
And so this 868 is, whatever's left of the 1250, and then the big blind's EV will be, whatever is left from the 1250. So, okay, so as a result, the relationship's direct. If you add $1 of EV to the small blind, you take it away from the big blind. If the EV for the small blind is 1250, then the EV for the big blind is 0. If the EV for the big blind is 1250, then the EV for the small blind is 0.
Gotcha.
So they always sum up to 1250. So every dollar you take away from the small blind, you put in the big blind's pocket. So in other words, maximizing maximizing your own EV is the same thing as minimizing your opponent's EV for a given decision or for a given, kind of strategy set.
Got it.
So for this, we're trying to make this 869 as low as possible. So
Right.
first we'll try never bluff catching. And the EV is 1,000, which makes sense because our opponent is,
He's bluffing us.
yeah, he's bluffing 80% of the time. So he wins that 1250 80% of the time. Well, 0.8. And so what is the big blind's EV then?
250.
And how would you calculate that?
Pot minus EV of small blind.
Yeah, but also the big blind is winning 1250 this 20% of the time.
Okay.
So that's kind of another way of reaching that. So let's say the bluffer bets or the better bluffs 100% of the time.
Mm-hmm.
What's the caller's pot odds?
It's 1,000 to win 2250.
And this formula we're going to use is risk divided by risk plus reward. And this is going to come up probably 1,000 times.
So 1,000 divided by 1,000 plus 1250.
So since we're calling here, our reward is more than 1250.
It's 2250.
Yeah. So, I mean, you've seen this before. Like this is, if we estimate that we win 30.7% of the time, that we would call, or it would be break even. You follow that so far, right?
Yeah, it's pot odds, right?
Yeah. And then what's the caller's chance of winning against the bet?
His chance of winning versus bet. What does he have? He has a pair.
So he's going to bluff 100% of the time.
Mm-hmm.
And he's also going to value bet 100% of the time. So he's either going to have quads or he's going to have 8-7 of hearts.
So 50%.
Right. So what does that tell us?
Tells us a few things. I don't know. What does it tell us? What's the most valuable information here?
There's nothing overly, I don't know. But basically, we're going to win 50% of the time, and we only need to win 30% of the time.
Mm-hmm.
So we're just going to call, and we're going to always call. There's no reason not to in this situation. So that's what it means on a very simple level. That's what it means to exploit someone. You know his strategy. In this case, he's not bluffing, or he's bluffing too often. Since he's bluffing too often, you're going to pick him off.
Mm-hmm.
Okay, so this table I filled out already because I don't want to spend too much time on this sort of thing. But for all the viewers, just make sure that you follow along with this, with what I'm doing here, and I'll walk you through it. So when our EV of calling with the 6-5, if our opponent folds, which if he's always bluffing, how often is he folding in this game?
Never.
And how often is he betting? Always. What is our one at what are our chances of winning? We already found that. That's 50%, right?
Mm-hmm.
We do the exact same thing where we can multiply them together and we get this new range of sorts. So 50% of the time he's going to bet a better hand, 50% of the time he's going to bet a worse hand, and he's never going to fold. Does that make sense?
Yeah.
Again, our final stack, if he folds, then we're going to have our 1,000 plus the 1,250 in the pot. If he bets and we catch him bluffing, we're going to win his stack. We're going to have our stack already. We're going to win the money in the pot. And if he bets and we fold, again, our EV, I'm sorry, if he bets and we call and we lose, we're going to be broke.
Mm-hmm.
You multiply all these together times the net here. So this would be 1,250 times the 0%. This would be 2,250 times this new percent here. or times these two together. So the EV of calling is 625, and the EV of folding we know is 0, so we'd call.
Mm-hmm.
And again, we can see the 625 matches up. So we can see where this EV number is coming from, how it's calculated. So now we'll get to something a little bit more interesting than that. We could also see that if he bluffs 50% of the time, then we would still call. Our EV is 375.
Okay.
So let's look at some exploitive strategies. And what we're going to do is you pick a bluffing frequency, and I'm going to pick a calling frequency. And we'll do it like 5 times.
Okay.
So how often do you want to bluff?
5%.
And pick like five bluffing frequencies.
Okay. 100%. 90%. 50%. 25%.
So this is why understanding how the game works is, or understanding kind of the solution, or not necessarily the solution even, but how the underlying numbers work, can make someone so lethal with exploiting. So I know the solution to this game, so I can always make the right choice here if I know how you're playing. If I were to do the same thing, if I were to and maybe that's not a bad idea. I'll pick a bluffing frequency, and you'll tell me what you would do.
Mm-hmm.
You're going to call or fold. Let's say I bluff 50%. Will you call or fold here with the 6-5?
Call.
Let's say I bluff 30%.
Fold.
Let's say I bluff 45%.
Fold.
Let's say I bluff 40%.
Fold.
Let's say I bluff 60%. So you're obviously going to call because you called the other one. Okay, so when you're bluffing 5% of the time, I'm going to fold. When you're bluffing 100% of the time, I'm going to call. When you're bluffing 90% of the time, I'm going to call. When you're bluffing 50% of the time, I'm going to call. When you're bluffing 25% of the time, I'm going to fold. Okay, so this is what this graph is now showing us. So the EV here is the EV of my choice, and this is the EV of the other choice. So this black line here is the solution to the game, the EV of the solution to the game. If you played perfectly as a bluffer, this would always be my EV.
Okay.
So what I've managed to do is I've managed to always pick an option that beats the solution, that beats the optimal percent.
Okay.
Because I know the solution to the game. So I always know exactly the choice to make. So even though here, and we can go through, it's going to take a long time again. I think it's good to do. But we'll go through your choices. And,
yeah, can we compare the two lines?
All right, so remember what this looked like. We have this black line. We know that's the solution to the game. I always chose the best option. For trial 1, I chose the best option. Trial 2, all the trials, I chose the best option. And not only that, but all of my options were above this, this maximum that you should be allowing me to profit. So let's plug in your numbers and see what your graph looks like. So your line is you still managed to exploit me, but there was one decision you made that was actually worse than the optimal amount. And that was when I bet 45% and you folded. You actually should have called, and you missed out on, $6.25. So you did a very good job of exploiting it, but you didn't do it perfectly, because if I had told you the solution to the game, then you would have been able to do it perfectly.
Mm-hmm.
So that I think it illustrates why, being able to make good reads is a compliment. It's not like I'm saying you should do this instead of what you used to do. I'm saying this could take someone like you and just make you that much better, because you'd be able to use your good reads and apply it in a structured kind of way, rather than just saying, this seems like he's not bluffing enough, or this seems like he's bluffing too much.
Hmm.
But it does go to show how good your intuition is, because you're the only one that you didn't get right was right on the borderline.
Yeah, no, this is a really good illustration of the whole concept.
So the next question is, well, how often should the out of position player bluff? If he bluffs 100% of the time, then we're always going to call. So we know that. But the question is, how often should he bluff? Because, maybe that's not the best thing for him to always bluff and have us always call. So what are our pot odds?
Risk is 1,000. Reward is 2250.
Yep. And it's risk divided by risk plus reward. As we saw before, is that
31%.
exactly? It's a little more than 2 to 1. So let's fill out this new range, or kind of find this new range that our opponent can have if he bluffs, say, 50% of the time.
Mm-hmm.
So how many combos of deuces are there?
One.
How many
One.
Okay. Percentage of the old range. So we would, just for completeness, we would sum this up. And this is the old range here, before he bets or anything. So it's just, before he bets, what are the chances he has deuces?
33%.
Well, remember that we have 6-5.
Oh, so 50%.
And when he's got the nuts, he's always going to bet. And how often is he going to bluff?
50%.
50%. So now this is Bayes' theorem. We take, and to be honest with you, I think what you were saying is also probably true, but I'm not sure. Maybe someone can comment on that. But it was just a different context than what I was thinking about. So we have these combinations, and we weight them by a certain amount. In this case, we bet some percentage of the time. So how many effective combos, we can call them, will there be for deuces? So he's got one combination he's always betting in.
Mm-hmm.
So how many combinations?
One.
And how about for 8-7? If he's bluffing 50% of the time and he's got one combination.
One.
Oh, sorry, I spoiled that. Not one. Because what we're saying is
half the time he's...
Yeah, he's just folding. He's folding a half of a combination of 8-7.
Got it.
So multiply these together. What's well, let's sum these up, because it's the exact same thing as above. So he's got 1.5 new combinations, and it's the same thing as here, where we divide the number of combinations by the total combinations. So here we divide this 1 by 1.5. So that's 67% roughly. And this would be 0.5 divided by the 1.5. You following this?
Yes.
And if we want to find out how often we're actually betting, do you have any guess for how we would calculate that?
No.
So basically, before we had any action, our opponent had 2 combinations. After the action, he's got 1.5 combinations. So that's 1.5 bet combinations. So how many fold combinations will he have?
1/2.
So then what percentage of his range is he betting? If he's betting 1.5 and he's folding 0.5?
3/4.
Exactly. So he's betting 75% of the time. And this is Bayes. When you apply a certain range, and then let's say, you pick a certain range for, let's say, c-betting, and you want to look at what your c-betting range looks like. You would apply Bayes. You would, apply a weight, whether it's, 0, 100, or something in between, to each hand. You multiply it by the number of combinations, and you get this new range.
Okay.
So we can kind of look at this. So when our opponent bluffs 50% of the time, he's got 33.3% bluffs. When our opponent bluffs 25% of the time, his range that we're looking at when we're facing a bet has 20% bluffs. If he bluffs 75% of the time, then his range of bluffs is like 43%. Like when we face a bet, he's going to be bluffing 43% of the time.
Okay.
You following all this? I mean, I think
Yeah.
intuitively it makes sense, but it's also good to it's kind of see how the numbers work. And of course, if he's always bluffing, then we saw before he's going to have 50% bluffs. We're going to have 50% equity. If he never bluffs, then of course we're always going to lose. So let's move past this, and hopefully everyone can fill this out. But we can look at the EV of calling, and we can look at the EV of folding based on everything that we've already gone over. If anyone watching, I would definitely recommend filling out this table or making sure that you can fill out this table. So this is given a 50% bluffing frequency. We see that calling is better than folding, and we saw that before also with this. So what was it? Was there a 50% in here?
Mm-hmm.
Yeah, 375 and 312.50. 375 and 313. So the next thing that we can ask ourselves is, we could play the same sort of exploitive game. So I'm going to pick a bluff frequency, and you're going to tell me, or can you tell me whether or not you'd call or fold? And now it should be easy because the EV is right in front of you. You got your EV of calling right here, and you've got your EV of folding right here.
Mm-hmm.
So let's say I bluff 25% of the time.
Fold.
So you're going to fold, and your EV is 469.
Mm-hmm.
Let's say I go 30% of the time.
Fold.
And it's 438. How about now?
Fold.
And how about now?
Fold.
And notice how we keep going down.
Mm-hmm. So you're finding the optimal bluff strategy?
Yeah, there's some point where you'll be indifferent toward calling and folding, and it just so happens we can plot this out. And actually, I'll have it here. So this is the plot of the green is folding, and the bottom is our opponent's bluffing frequency.
Mm-hmm.
So the more our opponent bluffs, the lower our EV of. Wait, why does that go down? Okay, so I have to explain this. So the EV of folding, why is it not 0 in this context? And I explained that before a little bit. So, take this example where our opponent never bluffs. So what's the EV of, or why is the EV of folding positive?
Why is the EV of folding positive if our opponent never bluffs? Because...
Oh, I'm sorry. So I'll make it make more sense. If our intention is to fold, then how can we make money with that line? If it's just our intention.
How can we make money by folding?
We know if he bets, we will fold, and our EV is 0. So where is the money coming from? So where is the 625 coming from?
Not calling.
Well, let's look across this line. So this is where the 625 is coming from.
Okay.
So what's happening here? Why are we netting 1250, or why is our final stack 2250 sometimes?
Why is our final stack 2250 sometimes if he's bluffing? Oh, well, if he's never bluffing?
Yeah.
I don't know the answer to that.
So the answer is we're just looking at the whole strategy. There's a chance that it doesn't even you don't even have the option to call or fold. So if he's folding 50% of the time, then he's giving you the pot 50% of the time. So by folding his air, he's giving you money.
Okay.
So when we look at this chart down here, this is all bluff frequencies, and this is the EV of calling, and this is the EV of folding. So it looks strange that the EV of folding is not 0, but it's not really the EV of folding. It's the EV of this strategy choice that you've made. You've made a choice that when it gets to you, you're folding. When it doesn't get to you, you've won the pot. So that's why it's positive.
Mm-hmm.
Do you follow that?
Mm-hmm.
Okay, so we look at this graph. The more our opponent bluffs, the less we actually win at showdown. So obviously, when he bluffs 100% of the time, we're never getting to showdown. We're always folding. The EV is 0. If he ever folds, then the EV is a little bit positive and more positive. And as we saw just now, it's 625 when he never bluffs. Our EV of calling, the more he bluffs, obviously the more our EV is going to go up, right?
Mm-hmm.
So how would you pick your strategy? So this is your EV, these green and white lines. How would you pick your strategy at any given time? Like, let's say I'm going to bluff 30% of the time. How would you pick your strategy?
I would just look at what the highest EV play is when you're bluffing 30%.
Exactly. So this is basically going to be your strategy choice at any given time.
Right.
If I tell you my bluff frequency, you're going to have this sort of line. And there's this point, the bottom, the minimum of this little curve or whatever you call it. And that so happens to be, if we know his strategy and we're able to pick our best strategy, we're able to exploit him maximally at each stop, and he wants to stop us from doing that, he would bet 44.44444%. And I'll show you, this is where the minimax theorem comes from. So what have we effectively done? If you're bluffing, you've told me your strategy choice, and I'm choosing the best play no matter what. So what is naturally going to be your choice? Maybe I should restate that. You're telling me your strategy. You're telling me your bluff frequency. I'm always picking the max here.
Mm-hmm.
And we know that the more EV I have, the less EV you have. So what would be the best point for you to maximize your EV and to minimize my EV?
The midpoint.
Yeah, this 44.44%. And we can kind of plug this into Carboner's EV. And let's say the bluff frequency is 44.44444%. And we can run this little chart thing. And we want to see what when our opponent bluff catches at different frequencies, how his EV changes. Okay, so let's let variable 2 go from 0 to 100. So our opponent's going to try a bunch of different strategies, given that we're bluffing 44.4% of the time. And for each of his strategies, the EV, you can see, is exactly the same. So it doesn't matter what he does. We're always making 902.78, and he's always making 1250 minus 902.78. Oops, you follow that?
Yep.
And again, we could fill out the EV table again, and you can see that when our opponent, or the I guess the equity table, and you can see that when your opponent bluffs 44.44%, that your pot odds are break even relative to the pot. So you're indifferent between calling and folding.
Mm-hmm.
So that's all that I want to show for today. But let's I want to go quickly over some homework assignments, then I want to go back to those questions, see if we can quickly answer them. So the first question, and Jay, you don't need to answer these, but I think these are just good thought exercises or things to work on. Why are we not in equilibrium now? We've just found that this is the case, but I'll tell you right now we're not at equilibrium. So why is that the case?
So a little hint for figuring that out. So consider we just had the situation where we're betting trying to make the caller indifferent. Well, flip the situation around and imagine you're the caller trying to make the bettor indifferent to bluffing.
What formula do we use to make a hand indifferent? And we use this formula in this video. How can you find the Nash equilibrium? Hopefully, based on everything that we went over today, that's something that everyone can do. And of course, I'm happy to answer any questions regarding that. See if you can solve the game for when the out-of-position player always checks. So right now, the out-of-position player has the option of either betting or open folding. So these games are very similar to the ones in the book, The Mathematics of Poker. What kind of happens with this whole idea of making someone indifferent? Because if you think about it, you can't make someone indifferent with the nuts. So we're not always. I think there's a little bit of a misconception that game theory is just always making people indifferent with all their hands, and it's this big thing of doesn't matter what anyone does. But that's not the case. There's only something that is being break even. or indifferent, I should say. So after going over this, what's equity?
What is equity? I would have a very similar answer to what I had earlier.
Yeah, I think your answer is definitely good, and something that we're going to look at beyond this is board runouts, because if you think about it, there's this big tree of all possibilities. If we're betting the turn, there's the possibility that our opponent calls. There's the possibility that our opponent raises. There's the possibility that we call and the river's the ace of spades. There's a possibility, I'm sorry, our opponent calls and the river's the ace of spades. There's a possibility our opponent calls and the river's the queen of spades. So equity kind of takes all of these possibilities into consideration, and your winning percent times those, and you get something of a weighted average for that. So what does EV tell us, and how do we calculate it?
I don't know. My brain is mush at this point. What does EV tell us? I feel like I would still have a similar answer that I did.
The one thing that I would add, though, is EV by itself doesn't really tell us anything. We need to compare the EV of all possible strategic decisions. And that's something that's really important, because I think, this is more for like beginning players, but they kind of think, all right, I'm going to bluff raise here. I think it's plus EV, but they don't necessarily think about, what's the EV of calling or.
Right. So it's always about it in evaluating EV in terms of relative to all of the other options we have at hand.
Exactly. And that's just so important. And it's very similar. EV and equity are similar, except equity is the chances that you win weighted by the chances of each of those events happening. EV is your profit, weighted by the chances of each of those events happening.
Okay.
So why is game theory good for a great exploitive player?
Well, it can just make you much more lethal, as you would say, if you know the solutions to your opponent's strategies.
Yeah, I mean, what better way to spot a leak than knowing exactly, what a leak is, knowing when someone should be bluffing 44.4%, if they're bluffing 40%, or if you just have, this idea that someone is not bluffing enough, how do you respond? And this gives you, a very direct way of capitalizing on your good reads.
Yeah, it seems like I could, play with amazing precision, alter bet sizes to be extremely, just much more effective than it used to be kind of guesswork.
Yeah, exactly. And I think that's kind of a misperception, that people think that when people talk about playing game, trying to play game theoretically optimal, that they mean like throw away everything else. That's all you're trying to do. But that's not the case at all. It's just, there's always, if you have a good read on someone, absolutely, you should always use that. And when you don't have a read on someone, then this is, the perfect way to have to kind of go into your shell and not be able to, be exploited, or kind of maximize your own profit against someone who might be able to read you. So what's Bayes' theorem?
Oh, that's some bullshit proof some mathematician invented.
Okay. What's minimax?
That has to do with where the EV lines intersect, right?
Yeah. So I'm gonna do this. I kind of forgot to do. So if I tell you a bluff frequency, we did this on the graph. You get to pick either calling or folding, whichever's higher.
Uh-huh.
And we saw that my goal then is to, if I'm bluffing, to pick the frequency for bluffing that minimizes your EV, because that's also going to maximize my EV. So I pick a strategy, you max exploit me. You play as best as possible against that strategy. And given that you're doing that, I'm going to pick the strategy that minimizes your EV and maximizes my EV. So this point right here is the point at which, when you pick, if I tell you my strategy, you pick the best option, that's going to maximize my EV given that. And this is that same 44.44% point. So are you following that? Because this is like for poker and game theory, this is probably the most important thing by far.
Mm-hmm.
The idea that you want to pick a strategy, you let your opponent in some way exploit you. Your opponent knows your strategy, and you want to pick the strategy that is damaged the least by this fact that your opponent can read you perfectly.
Sure.
And what's a Nash equilibrium? We didn't quite get there, but maybe that's something to think on. Because like I posed, the first question I posed before was, why are we not in a Nash equilibrium here? It sort of looks like we are, but why aren't we? So maybe just think on that one, unless you have any sort of.
Not really. It's hard for me to say. Is this stuff hard to do? Yes, but a little bit easier now.
All right, that's good. And yeah, I mean, I know that there was more numbers than anyone probably wanted to see, but as we progress, I think there'll actually be less numbers and not more. So hopefully that'll be a good thing.
Well, yeah. I mean, numbers had to come in at some point in this odyssey.
It's true. It is math.
Yeah.
Game theory is math.
Yeah. Let's be real about it. Like, yeah. Early on, I knew there would be math and a lot of it at some point. So
Yeah, that's good. And there's nothing crazy. There's nothing difficult. And once you get these EV and equity things down, sometimes you don't even have to run them just because you have this intuitive idea of what the EV is. But yeah, we can wrap up there. Do you have any questions?
No. I try to with these sessions. I try to just take it all in and let it sit and let my mind think about it. His questions will just probably, lead to more overload. I feel like, personally with other people in the same position that I am, you kind of have to not push yourself over the limit. Don't take in too much too soon, or you'll just be very confused.
Yeah, that's definitely the case. And I guess that's also what's kind of nice about a video is anyone can, review it again if need be, or pause it, take notes or whatever. Because yeah, I think this, like I said, this is the foundation. So stuff's really important. But yeah, thanks for talking with me. I'm really excited about where we're going to take this.
Yeah, me too. Yeah, go math. Go math.
Never tell me the odds.
Okay.
All right, so we'll see you all in 2 weeks. Comments and questions always very much appreciated, and thanks everyone.
See you guys.